In this video, I'm going to share some thoughts about how we measure income inequality, looking at the Lorenz curve and the Gini coefficient. I'm going to show you how these are calculated and give you some insights about some problems with how we typically measure income inequality and talk about income inequality, in my opinion. So the Lorenz curve is a graph, and this is the formal definition of a Lorenz curve, uh, invented by Lorenz in a paper published in 1905. So it's kind of an old idea, and it's basically graphing a set of points where you're adding up the population from lowest income to highest income, and adding up income in a cumulative way as you go. Let's look at an example here, right? That I've created these numbers for incomes to kind of mimic the income distribution in the United States that we see right now. So what you do to make a Lorenz curve is you divide people into groups. Easiest way to do it is to divide people into 5 or 10 or 50 equal sized groups. And then you order these people from the lowest income to the highest income. For a simple example, let's just assume we have 5 people, or we could just as easily talk about 5 groups of people that are of equal size. And in the first group, the average income is $1, or the first person earns $1. In the second group, the average income is $3. The third group, the middle group, is the average is $5. The next group, the average is $7, and in the highest income group, the average income is $17. Now, what I've done is taken the actual average incomes of the 5 quintiles, the 5 equally sized groups in the United States. If you divide them into the bottom 20%, etc., that these numbers are in a similar proportion to each other as the average income in those groups are. So the average income in the top group is about 17 times as much as the average income in the bottom group, just to make it as simple to compare these things. So in order to make a Lorenz curve, what you do is you line up the people from poorest to richest, so person 1, 2, 3, 4, 5. And along the x-axis on a graph, we add up the percent of the population that we're talking about from poorest to richest. So when we add the first person, we're talking about the bottom 20% of the population. When we add in the second person, we're talking about the bottom 40%. When we add in the third person, 3 out of 5 is 60%, 4 out of 5 is 80%, and 5 out of 5 will be 100%. So we add up the people along the x-axis, and we add up the income, the total income received by that percentage of the people on the y-axis. So in this table, here's the cumulative proportion of people, 20, 40, 60, 80, and 100%. And here is the percent of income each of these groups earn. The lowest, 3%. The next lowest, 9%, the next lowest, 15%, the next lowest, 21%. And in the United States, the top 20%, or the top quintile, earn about 52% of the income. What we do to make the Lorenz curve is we add up these percentages. So the bottom 20% earns 3% of the income, or 0.03. When we add in the next 20%, of people's income, we add in the 9% of income they earn to get 12%. And then we add in the 15% that the next group earns to get 27. And then we add in the 21% of the next group of people to get 48. And then this last point is always going to be 100%. We add in the top group's percent of income earned. And we plot those points along a curve here, and we call that the Lorenz curve. So we always want to compare the Lorenz curve visually to a straight line connecting 0, 0 and 100%, 100%. And we call that line the line of perfect equality, because what it would represent is if we had a country whose Lorenz curve were a straight line like this, then the bottom 20% would earn 20% of the income. The bottom 40% would earn 40% of the income. The bottom 60% would earn 60% of the income. Everybody would be equal. Every income group would get the same proportion of the income. And visually, what we're looking for is a sign of income inequality is how far does this Lorenz curve dip below this line of perfect equality. As incomes get more and more unequal, this Lorenz curve is going to dip further and further and further down toward the x-axis, meaning that more and more of the income is earned by the top percent and less by people in the lower percents of income. Now, how do we actually measure this? It's great to have a visual way to look at income inequality, but we always also want a way to quantify income inequality. And how we do that is by looking at something we call the Gini Coefficient. And this was invented by a guy named Corrado Gini. He was an Italian. And in 1914, he published a paper where he said, okay, let's take this Lorenz curve, which is this green line through the middle, and let's calculate the following fraction. Let's calculate the area between the line of perfect equality and the Lorenz curve, because the bigger that area A gets, the more income inequality there's going to be. So he said, just let's calculate the proportion of the whole area of this triangle, which is A plus B on the bottom. So the total area of the triangle is A plus B. Let's calculate what proportion of the area is taken up by A. And more unequal incomes will get larger and larger fractions of the triangle taken up by the A part. So Gini is just A over A plus B. And there's two ways that people will represent Ginis. Sometimes it's a number between 0 and 1, and sometimes people will multiply those numbers by 100 to get a number between 0 and 100. The easy way to tell is if you ever see a Gini coefficient written as a number bigger than 1, you know that they multiplied them by 100. So with this example we were looking at before that is designed to mimic the income distribution in the United States right now, we get a Gini coefficient of about 0.436. And that's not too far off from the truth. We're about 0.44 or about 0.45. It's important not to try to interpret this Gini number as being a percent of anything, or it's really hard to interpret the number with a concrete meaning. It's just a geometrical interpretation of how big this area is compared to an entire triangle if we drew a triangle using that line of perfect equality. The best way to try to compare Ginis is just to look at a bunch of different Gini coefficients and think about where the Gini coefficient numbers came from. Let's look at another numerical example. Look at the Lorenz curve and look at what Gini coefficient that would give. So here, just to keep in mind, this is kind of like the United States, where the poorest 20% earn $1. The next 20% earn 3 times as much on average. The middle group earns about 5 times as much as the poorest group on average. The upper middle class, you might think about it, of households earn about 7 times as much. And then the upper 20% earn about 17 times as much on average as those in the poorest 20%. Now, let's look at a little bit more extreme inequality example. What if the 5 people consisted of 4 people who all earned $1, and then there's one rich person? Or, an alternative way to think about it is the poorest 20% the next 20, the next 20, and the next 20% all earn about $1 uh, per person on average. But then the upper 20% earn 21 times as much. This would be a very, very unequal kind of society. Here's what the Lorenz curve would look like, leaving a large gap here between the line of equality and the Lorenz curve. And when you do that with those numbers and you calculate the Gini coefficient, you get a number of 0.64. Let's look at some worldwide Gini coefficients here to get a feel for what the range of values in the real world is. About the highest Gini coefficient I've ever seen is about a 0.7 or so. It's kind of hard in the real world to have a much higher income inequality than about a 0.7 or maybe 0.75. One of the highest currently, and the source of this data is the CIA World Factbook. And some of these Gini coefficients are relatively recent. Some of them are from 5 or 10 years ago. I just used the most recent numbers that the CIA World Factbook has. And you can see South Africa has very high income inequality, a very high Gini coefficient. Sierra Leone, also very high. Panama, also very high. Mexico, pretty high. In the United States, this is a number that was calculated in the World Factbook in 2009, I believe. So about 0.45. In Nigeria, a little bit lower than the United States. Ghana, a little bit lower still, about 0.394. Japan, even lower. India, even lower inequality. And so I've got these in descending order of income inequality. One of the most equally distributed income countries you'll find is Sweden. Very equal income distribution in Sweden, with a Gini coefficient of only about 0.230. So, let me tell you some other things about the Gini coefficient and some other interesting things you can see with the Lorenz curve. There's something we call the Robin Hood index. And the Robin Hood index is if you take a line and you put it right here at the 50th percentile of population. You're looking at the median person with the median amount of income. If you measure the distance on the y-axis here between the Lorenz curve and the line of perfect equality, then that distance, which in this graph looks to be somewhere, maybe the bottom there is about 0.2 and the top is about 0.5, that distance between 50%, this is basically telling us that if the income were totally equal, if the income were totally equal, then the bottom 50% would have 50% of the income. In reality, they only have about 20%. So the Robin Hood index, that 30% difference in the amount they have versus what they would have to have a perfectly equal income distribution, is called the Robin Hood index because it tells us that 30% of the income of those above the median would have to be transferred to those below the median in order to even out the income distribution. And Robin Hood was famous for taking from the rich and giving to the poor. That's why we call it a Robin Hood index. Now, there's a sort of simple way to calculate the Gini coefficient. And why do I say simple? Well, because in the real world, if you want to calculate all those areas, say the area of this lens between the line of perfect equality and the Lorenz curve, that could get complicated, especially if you're computing this using 10 groups or 20 groups or unequal sized groups. It's actually possible to make a Lorenz curve with unequally sized groups. You're going to have some computational difficulties, adding up what that area is and comparing it to the entire triangle. So this is a more convenient formula for computing the Gini coefficient, and I've done it with that first example here to show you how this formula would work out. And even though I was skeptical when I first saw this formula, it looks a little too simple and it looks like it's doing something very fishy. It does work. And what the formula says is for each group, from the first group, I equals 1, to the fifth group, if you have 5 groups of people, take 2 times the number of the group you're looking at. So here 2 times 1 would be 2, down here in the bottom, minus n. Well, n is the 5 groups, so you subtract the 5, minus 1. Okay, you just subtract 1. And then you multiply that times x, which is the average income of the people in that group. And in our example, that was 1 for the first group. And then you repeat this process for the second group, the third group, the fourth group, and the fifth group. And you sum all those numbers on the top, and you divide it by n squared, which in this case is 5 squared, times the average income. And the average of 1, 3, 5, 7, and 17 is 6.6. Then you get the Gini coefficient, 0.436. Again, it looks like a very odd formula to be calculating an area and then calculating the proportion of that area, but trust me, it works. These are some Lorenz curves that I calculated for some counties in North Carolina in the United States of America, just to show you, again, some other examples about how different Gini coefficients look differently with different Lorenz curves. I live in Guilford County, and we're kind of about an average Gini coefficient, similar to the United States Gini coefficient of about 0.45. The county in my state that has the least amount of income inequality is Onslow County, with a Gini coefficient of 0.386. And the one with the highest income inequality is Northampton with a 0.508. That's the green Lorenz curve down there. Now, what are some problems with using Gini coefficients and Lorenz curves to talk about income inequality, at least the way it's commonly done? Let me just point out some problems that I have with this. First problem I have is we use household income usually when we measure income inequality with a Gini coefficient. Now this isn't bad in itself, but I want you to think about what a household means, at least in the United States, when we collect these figures. The definition of a household, according to the Census Bureau, is it consists of all the people who occupy a housing unit. Well, that makes sense. A house could be an apartment, or other group of rooms, or it could even be a single room. And it's regarding as a housing unit when it is occupied or intended for occupancy as separate living quarters. So, what kinds of things count as a household? A dorm room for students, so it could be a single student living in a dorm room. That's a household. Probably with low income. It also could be a house with 20 people living in it. So the definition of a household, when you're talking about household income, because you're not comparing apples to apples, it could affect how you're measuring income inequality. A second problem with using the household to measure income inequality is that over time in a country, often the structure of households will change. The average size of a household in the United States used to be much, much larger than the average size of a household now. 100 years ago, it was very common to have at least 3 generations living in a household. You'd have the grandparents, you'd have the parents, and you'd have children. These days, there are many more people who are living alone in an apartment, and that's a household. So as the average size of a household gets smaller, that can increase the apparent calculation of income inequality, even when nothing really is going on with income inequality. Another problem, possible concern, of using the standard methods that usually governments will use to calculate measures of income inequality is that we use measures of income before we take into account the taxes people have to take out of their income to pay to government, and before most transfers like welfare payments, earned income tax credits, housing benefits, and other sorts of things. If we're trying to measure income inequality to get a feel for how the quality of life is different and track that, then this is going to distort things because people with very high incomes will normally pay a very high percent of their income in income taxes. People in the bottom 20% will generally be getting some transfers from government that make their income really higher, their effective income higher. Right now in the United States, more than half of people in the United States get some sort of handout. And by handout, I mean some kind of welfare payment or subsidy for health insurance or some of their rent paid for by the government or some kind of food program assistance. And if you don't count all those sources of income, then it's going to make income inequality look a lot bigger than it really is. Typically, we see that the United States Gini Coefficient, if we calculate this the way we typically do it, is somewhere around 0.44. It goes up a little and down a little over time. But if you measure income inequality without taking into account any taxes or any transfers of any kind, of course, that's going to make the income inequality look worse. It goes up to about 0.48. But if you carefully adjust for all the taxes people pay and all of the transfers like the earned income tax credit and other programs that people get money and other sorts of living assistance, then the Gini coefficient drops quite considerably to 0.344. This is similar to the Gini coefficient for Sweden that we were seeing before. Let's just visualize the difference in the Lorenz curves between these three methods. So this is what the typical Lorenz curve in the United States would look like. This is the higher Gini coefficient Lorenz curve in red if we take out ignore all the taxes and ignore all the transfers. And here's what in blue the Lorenz curve looks like if you do account for those other sources of income and do account for the fact that the people in the higher income group are going to be losing a lot of their income in taxes. A third problem that I see with looking at income inequality and trying to track what happens over time, because this is something that comes up in the news and a lot of pundits discuss this on television, complaining that income inequality is getting worse and worse, especially in the United States. And if you look at the Gini coefficient in 1970, it was about 0.394, and it has indeed gotten larger over time, at least until 2007. And this is when we had the big recession start to have some of its impacts, and that caused the Gini coefficient to go down just a little bit. But now we see that the Gini coefficient is going back up again. Why is it hard to make a judgment about what's going on and to really be convinced that income inequality is indeed getting worse in the United States? Well, one problem I mentioned before, that the composition of households is changing. And as households get smaller, you're going to have some small households with less income compared to some still larger households who might have 3 or 4 earners in the household, and that's going to make the apparent measures of income inequality worse and worse. Another thing that I haven't heard anybody really talk about much is the effect of immigration on income inequality. And this is just something to think about, just food for thought here. That back in 1970, when the income inequality measure, the Gini coefficient, was 0.394, only 4.7% of the population was foreign born, so immigrant share of the population. Now, since that time, the share of immigrants has gone up to, in 2010, almost 13%, and right now in the United States, it's over 13%. Now, by pointing this out, I'm not trying to say anything bad about immigrants, but I just want you to think about two of the common sources of immigrants into the United States. One source is kind of on the higher income end of the scale, and these are H-1B visas, where corporations will spend a lot of money to get in specialized people, computer programmers, or people with specialized technology skills to work for them. Typically, these are high income immigrants. So that's one group of immigration that has increased quite a bit since the 1970s, certainly. Another source of immigration that people talk about a lot is illegal immigration. And quite a few illegal immigrants are going to be in the lower 20%, in that first quintile. And so if we have almost 3 times as many immigrants in the United States in 2010 as we did in 1970. And some of those immigrants are people who are being brought in on special visas because they are going to have high incomes. And another fairly decent sized group of those immigrants is coming into the United States illegally, which is going to limit the kinds of incomes that they're going to be able to make. That is likely to increase income inequality. And so if we don't take this into account, it's going to be hard to make a judgment about what's going on with people who, with the income inequality of people who have been in the United States. If we were to track the same people over time, rather than adding in another approximately 10% of new people coming into the country, it kind of makes it hard to judge what the real trends are. And here I just made a little scatter plot over on the right with the percent of the population in the United States who are immigrants on the x-axis and the Gini coefficient on the y-axis. And we do see a correlation here. And I can't make the claim, and wouldn't make the claim, that correlation is causation, but it's something that I think it's interesting to look at, and it would be good to try to investigate what is happening to the Gini coefficient if we could remove the effect of the recent immigrants out to see if the Gini coefficient is really going up at the same rate as if we include the immigrants. So that's all I have to say about the Gini coefficient and Lorenz curves. As always, if you have questions or comments, please leave them in the comment section below. I appreciate your time and good luck with your studies.